current and electricity. This chapter and the next chapter, magnetic effect of electric current, in both chapters we are going to study about charge and their properties, right? So it is necessary for us to know some basic about the charge, right? So our first topic is going to be charge. So what is charge? Charge is the property of any object due to which the object can exert or experience electrical or magnetic effect. Once again, what is charge? So charge is property of any object due to which the object exerts or experiences electrical or magnetic effect. So it is the property it is the property of an object due to which the object can exert or experiences electrical or magnetic effect. Electrical or magnetic effect, right? So charge is associated with any object due to which it can exert or experience what? Electrical or magnetic effect. Charge is basically represented by Q. Its SI unit is Coulomb, and it is represented by symbol C, and it is a scalar quantity. It is a scalar quantity. What is a scalar quantity? So we know there are two types of quantity, a scalar and vector quantity. Scalar quantities are those which only require magnitude for its complete representation, magnitude and its unit, whereas another is a vector quantity, those quantities which require magnitude, unit and direction for their representation. So here only require magnitude and unit. So and we also know that it follows simple rule of algebra. What does that mean? 1 plus 1 2, 2 plus 2 4, right? So suppose suppose we are going to add 1 kg plus 2 kg. How many kgs? So obviously 1 plus 2 3 kgs. But if we are going to add a force of 1 Newton and another force of 1 Newton. So what will be the resultant of 1 Newton and 1 Newton? See, the direction is opposite to each other. So we already know that the net force will be 0. And another example, suppose the force acting on these objects are along the same direction. So what will be the net force? So it will be 1 plus 1. How many? 2 Newton. So here we have two forces, each of magnitude 1 Newton, but in one case 0 and in other case 2 Newton. So here the quantity force requires magnitude as well as direction for representation, right? यहाँ पे in first case the direction is opposite to each other, then net force is 0. But when the force the direction of the force is same, then it is 2 Newton. But if we are going to add 1 kg plus 1 or 2 kg, it will always be 3 kg. It does not depend on the direction, right? So that means mass is a scalar quantity. In similar manner, charge is also a scalar quantity. Hope it is clear. So charges are of two types. Charge is of two types, positive and negative, right? So positive charge and negative charge. And we know that similar charge repel each other and opposite charge attract each other. So these are the, we can say, the property of the charges. What? Similar charge repel each other and opposite charge attract each other. Generally, positive charge we take a proton and negative we take a electron, because they are the basic charge carrier in any atom. This is the smallest charge. It is the smallest charge, and we know that proton is positive charge and the charge on proton is plus 1.6 into 10 to the power minus 19 coulomb, and the charge on electron is minus 1.6 into 10 to the power minus 19 coulomb. See here, the charge on proton and electron is equal but opposite in nature. Positive on proton, negative on electron. So we knew that these both charges are opposite to each other. Their nature is opposite to each other, right? So there are so many things that are opposite to each other. Their nature is opposite to each other. Suppose day and night, right? They are opposite to each other. Day and night, we can say sky and ground, right? So why we specifically taken positive and negative charge? Because when proton and electron get added, so what will be net charge? It will be 0. So when electron and proton are added, then the particle becomes chargeless. So it is only possible in mathematical operation that when two quantities same magnitude but opposite nature get added, then it becomes 0. Suppose minus 5 plus 5, how much? 0. Minus 10 plus 10, how much? 0. But can we add day and night to 0? Will it become 0? No. So I think it's clear why charges are termed as positive and negative. And this is convention, right? Ki the charge on electron is negative and charge on proton is positive. Now we are going to talk about properties of charges. So properties of charges. Properties of charges. So there are so many properties. Two of them we already have learned, like charges are scalar quantities, and similar charge repel, opposite charge attract, right? So now we are going to talk more the properties of charges. Additivity of charge. What does that mean? Simple addition of charge. Suppose a system has two charges or three charges, Q1, Q2, Q3. The net charge on the system will be the summation of total charges, right? So suppose a system having charge Q1, Q2, Q3, Q4, right? So net charge on the system will be the summation, right? The summation of all the individual charges, right? So Q1 plus Q2 plus Q3, Q4 is negative, so minus Q4. So this is net charge on the system. suppose we are going to take another example, plus 4 coulomb, 3 coulomb, minus 6 coulomb. So what will be net charge? So net charge will be so 4 plus 3 minus 6 is equal to plus 1 coulomb, right? So first properties of charges are additivity of the charges. Hope I am clear. Second is quantization of charge. What? Quantization. Quantization of charge. So what is quantization of charge? So charge on any object is integer multiple of charge on basic charge carrier. So charge on any object is integer multiple of charge on any object is integer multiple of charge on basic charge carrier. Basic charge carrier. So what is basic charge carrier? We already know that the electron and proton are basic charge carrier. So Q, suppose Q is the charge on any object, will be equal to plus minus n into P, where n is number of electrons lost or gained. So it will always be in integer 1, 2, 3, 4, right? And E is electronic charge 1.6 into 10 to the power minus 19 coulomb, right? So let's study about it. So let's try to understand this concept. Suppose we are going to take an example of any atom. Suppose we are going to take sodium atom, right? Sodium atom. We all know that sodium has how many protons? 11. So number of proton will be 11, right? And we already know that sodium has 11 electron, because the element has same number of electron and same number of proton in elemental state, right? We know that. And these are the only basic particle which carries this charge. We let's quickly revise some topic of about atom. We know that every atom is consist of three basic element: electron, proton, and a neutron. Electron revolves in a circular path around the nucleus. Proton and neutron are in the nucleus, right? First thing. Second, electron has got negative charge of minus 1.6 into 10 to the power minus 19 coulomb, and proton having charge of plus 1.6 into 10 to the power minus 19 coulomb, and neutron is chargeless. So we all know that only proton and electron are the particle which has got charge, right? So if we are going to give or take charge, then we have to give either electron or proton, and we know that proton is in the nucleus, so it will be very difficult to transfer the proton. It is not impossible, but it will be very difficult. It will require very large amount of energy. So generally in charge the electron takes place. I can say that in the transfer of charge, the transfer of electron takes place, right? So I think it is clear, right? One more thing, see, electron revolves around the circular path, around the nucleus in a circular path, and proton is in the nucleus. So to remove the proton, it will be very difficult, right? We require a lot of energy, but if we are going to give some certain amount of energy, then electron can eject, it can transfer from one atom to another, and it will participate in the transfer of charge, right? So we are going to take the example of sodium. So sodium has 11 electron and 11 proton. So what is the net charge on the sodium? Net charge. So we know that the charge on proton is 1.6 into 10 to the power minus 19 coulomb. And how many protons? So 11. So number of proton into charge on proton, number of electron into charge on electron. This is the total charge, right? So it will be 11 into 1.6 into 10 to the power minus 19 plus 11 into minus 1.6. Why minus 1.6? Because the electron has got negative charge. So minus 1.6 into 10 to the power minus 19 coulomb. So it will be equal to 0 coulomb, right? So we already know that every element in elemental state has got 0 charge. So now we have proved that. So suppose if this sodium atom loses an electron, right? It loses an electron. So how many electrons now it will have? So 10 electron, but proton, the number of proton is same, so number of proton is 11. Now what will be net charge? So Q net will be again number of proton into charge on proton, number of electron into charge on electron. So it will be 11 into 1.6 into 10 to the power minus 19, or 10 into minus 1.6 into 10 to the power minus 19. So 11 minus 10, how many? 1 into 1.6 into 10 to the power minus 19. So this will be net charge. So what is the nature of net charge? It is positive. 11 minus 10, positive. So 1 positive, right? So we can conclude that if an object loses electron, it will acquire positive charge, and similarly if an object gains electron, it will acquire negative charge. Hope it is clear. And one more thing, if sodium atom loses 1 electron, it has got 1 into 1.6 into 10 to the power minus 19 coulomb. Suppose if another element, magnesium, loses 2 electrons, how many? 2 electrons. So how many charges it acquires? So electron is losing. Electron losing, loss of electron means positive charge, and net charge will be how many electron it is losing? 2. Here 1 electron, so 1. Here 2, so plus 2 into electronic charge 1.6 into 10 to the power minus 19 coulomb. Suppose if an object A loses an electron, so how many charge it will get? Obviously it will get positive charge. So how many net charge? So Q, how many electron it is losing? N. So plus N, and E, what? Electronic charge, right? Clear? So suppose another object B, it is gaining plus N electron, right? So the net charge on the object will be negative, right? So what will be net charge? So Q will be equal to minus y minus, sorry, y minus, because it is gaining electron, so minus n into E. So if we are combining 1 and 2, can we write that Q is equal to plus minus n into E? Yes, we can write, where n is number of electron lost or gained and E is electronic charge. So hope we are clear, right? Okay. And third property is conservation of charge. Conservation of charge. So what is conservation of charge? The charge of any isolated object is always remain same. Suppose if we are in a room and we are two people, you and me, right? So you got 4 coulomb charge and I got 6 coulomb charge. So net will be 6 plus 4. How many? 10 coulomb charge, right? So if this room is completely closed, it is not possible to make transfer of charge, right? So if we both, neither you or neither me, going out of the room or any other person coming into the room, so the only charge in this room will be the charge you got and the charge me got, right? So conservation of charge states that charge of any isolated object remains same. Okay, so suppose if this system got two objects A and B, so the net charge remains same. Suppose it is chargeless, so it will always remain chargeless. But in case if we are going to transfer some electron from A to B, suppose we are going to transfer 2 electron from A to B, so A is losing the electron, right? So A will acquire plus 2 electron charge, right? And B will acquire minus 2 electron charge. So see here net charge is again 0, right? So we can create or destroy charge in pair, but the charge of isolated system remains same. Initially charge was 0, finally charge is 0, right? So charge remains same, but we can create charge in pair, like if we are going to create plus 2 coulomb charge on A, then it will be minus 2 coulomb charge on B, so net charge will be again 0. So today we are going to end here. See you in the next class. Thank you.